In this video, we'll generate the dataset trend line of exponential decay and exponential saturation models. So first to begin with the exponential decay. So array formula, exponent minus x, so that's decay, so negative x. And here's the decay model. And generate the Taylor-Maclaurin series sum, which is the summation of a times x to the power n, where a the coefficient is negative 1 to the power n over n plus k factorial. Our value of k is 0 if it is decay, 0, and 1 if it is saturation. So we have two values, 0 and 1, 0 for decay. So we'll generate the values of n, starting from 0 to infinity. And we can generate up to 10, which is still good enough. So we can generate the Taylor-Maclaurin series sum, array formula, series sum of the x values, starting from k, incremented by 1, and the coefficient will be this range. So we can now work on the coefficients. So array formula, minus 1 to the power n, divided by factorial of n plus k, of n plus k. Enter. So that's decay. If you change 1, the expansion will be a saturation. So we'll go back to 0. Next, we calculate the regression coefficients using LINEST. To do that, we enter the 1, x matrix. So we have the 1, x matrix. Where we start with the power. So transpose from 0 to 10. So the rows and columns are the same. That means there's no degree of freedom. Now we calculate for the complete the the 1, x matrix, array formula of the x values raised to the power 0 to 10. Now we can use LINEST. So LINEST data y and data x. So we have the regression coefficients of the function itself. We can continue with the Taylor-Maclaurin series sum. So LINEST of the Taylor-Maclaurin series expansion and data x. Right now, the coefficients are the same. They have the same coefficients. And the trend lines are the same. So the red line covers the blue line because they're the same, because the regression coefficients are the same. If I change the value of k to 1, the expansion coefficients change. 1, 0, negative 1, 1, positive 0.5, negative 0.5, negative 1, negative 0.167, positive 0.167, plus 0.0417, negative 0.417. So you will see alternating coefficients. The signs of the coefficients are alternating against each other. And this is the decay, while this is the